I want you to do something for me right now. Take a second and actually look at the device you're using to listen to this. Maybe you're at a desk with a desktop tower humming away. Or, maybe you've got a laptop open.
Or even a gaming handheld. Those are getting popular.
Exactly. Now, chances are when you bought that device, you looked at the screen, maybe checked the battery life, typed on the keyboard. But there is a 90% chance that you didn't give a second thought to the actual brain inside that machine.
Which is funny because that brain almost certainly belongs to one single specific family that has, effectively run the entire world for the last 40 years.
We are talking about the x86 processor family. And I know, x86 sounds super technical, like a droid from Star Wars or something.
Yeah, or a secret government project.
Right. But it's actually the standard that defined the entire personal computer revolution.
It really is. It's the invisible engine. It's the closest thing we have to a global language for computing.
So our mission for this deep dive is to unpack exactly why this one family of chips run the tech war. We want to know why it matters for everything from, playing the latest games to crunching boring financial spreadsheets.
And the big question, why is it still the king of the hill after decades of people predicting its death?
To get that, you're saying we have to think about it differently, not just as a piece of hardware.
Exactly. We tend to think of a CPU as just silicon metal transistors. But x86 is better understood as a shared language.
A language. Okay, unpack that for me. Because when I look at a spec sheet, I see gigahertz and core counts, not grammar rules.
Right, but those are just metrics of speed. Yeah. The real identity of the chip is its instruction set architecture, the ISA. Think of that as the dictionary and the grammar that lets software talk to the hardware.
So something like Microsoft Word or Google Chrome, they're basically written to speak this x86 language.
Effectively, yes. They issue commands in x86, and any x86 chip just understands them. Now, this standard started with Intel way back in the late 70s. But the fascinating part, and this is what makes the story so unique, is that it's not just Intel anymore.
Right. We have to talk about the other giant in the room. AMD.
Exactly. AMD is a completely separate company, a fierce rival, yet they build chips that speak that exact same language.
Which is just wild when you think about it. You don't see Samsung making a processor that can run Apple's iOS natively.
No, you don't. But here, you have these two mortal enemies using the same playbook. Yeah. And that shared playbook is why x86 won.
Before this, it was just chaos, right?
A total Tower of Babel. If you bought a computer from Commodore, it couldn't run software written for an Apple, and IBM couldn't run stuff from another brand. It was a mess.
So x86 was the great unifier.
Precisely. This shared language meant a developer could write a program, let's say, the original Doom.
The classic.
A classic.
Yeah.
And they didn't have to worry if the user had an Intel chip or an AMD chip. As long as it was x86, the software just ran.
That's the why this matters moment, isn't it? It's the network effect. The more people used x86, the more software was built for it, which just made more people buy x86 hardware.
And that's why today, over 90% of every personal computer sold worldwide contains an x86 processor. It's the default setting for computing on this planet.
But it wasn't a straight line to get here. The history is actually pretty dramatic. It involves this huge war between Intel and AMD that literally shaped the computer I'm using right now.
It does. And to understand that war, we have to talk about the numbers. 16-bit, 32-bit, and 64-bit.
Okay. These terms get thrown around all the time in marketing. Now with 64-bit processing.
Yeah.
But what does that actually change for me, the user?
It basically changes how much information the computer can hold in its head at one time. If we go back from about 1978 to 94, in the early days, the 8286, the 286.
The era of the beige box, DOS prompts. The original Prince of Persia.
The beige boxes, exactly. Then, from about 95 to 2004, 32-bit became the absolute law of the land. This is the Pentium era, the AMD Athlon. And for a long time, 32-bit was more than enough.
But then we hit a wall, or a ceiling.
A ceiling is a great way to put it. We hit the memory wall. See, the mathematical limit of a 32-bit system is that it can only address or point to about 4 gigabytes of memory. Of RAM.
Which, to be fair, in 1998 seemed like an infinite amount of memory. I think our first PC had, 16 megabytes?
It did seem infinite. But by the early 2000s, video was getting better, games got bigger, databases were exploding, 4 gigabytes started to feel really, really claustrophobic.
So the computer literally couldn't see or use any memory beyond that 4 GB limit?
Nope. If you installed 8 GB of RAM, the computer would just ignore half of it. It couldn't see it.
So this is the turning point. Around 2003, and this is where the story gets really interesting, because it wasn't Intel who fixed this first, was it?
No, and this is one of the greatest underdog stories in tech. Intel actually wanted to move away from x86. They tried to launch a totally new 64-bit architecture called Itanium.
I vaguely remember that name. It was supposed to be the next big thing.
It was, but it had a fatal flaw. It wasn't compatible with all the old software. You had to start fresh. The market hated it. Meanwhile, AMD, the smaller rival, said, hey, what if we just extend x86? They introduced a 64-bit design called AMD 64.
So they took the existing language and just added more vocabulary to it?
That's a perfect analogy. And because it was backwards compatible, it ran all the old 32-bit stuff perfectly, but it also opened the door to the future. Microsoft looked at both options and basically said, we're going with AMD's way.
Wow, so AMD actually beat Intel at their own game.
They did. They forced Intel's hand. Intel eventually had to swallow their pride and license the tech from AMD. So the 64-bit standard we all use today is technically an AMD invention.
That's incredible. So putting the corporate drama aside for a second, what did this switch to 64-bit actually do for me?
It shattered that memory ceiling. Suddenly, computers weren't capped at 4 gigs. They could handle tens, eventually hundreds of gigabytes of RAM.
So practically speaking, that's why I can have like 100 tabs open in my browser while I'm editing a video, and the computer doesn't just melt.
Exactly. It allowed for massive data sets. It sped up everything from complex spreadsheets to HD video editing. It wasn't just a small step. It was a quantum leap in what a personal computer could do.
And now, from 2010 to today, 64-bit is just the air we breathe.
It is. Windows 11, Mac OS, Linux, they're all 64-bit first. In fact, we're at the point where 32-bit support is actively being dropped from new software.
Okay, so that's the history. I want to pivot now to the listener who's thinking, okay, cool story, but how does this affect my Tuesday morning? Let's talk about x86 in daily life.
Right. Well, let's look at the most common things people do: surfing the web and streaming video.
Which takes a deceptive amount of power, I think. People really underestimate how heavy the modern web is.
It's incredibly heavy. Modern websites are basically complex applications. Modern x86 processors have dedicated parts of the chip just for decoding high-definition video efficiently. That's why you can stream 4K from YouTube while having 20 other tabs open.
And then there's gaming. This is a huge one.
It's massive, and the overwhelming majority of PC games are written specifically for the x86 architecture.
It's not just PC, is it? The consoles, the PS5, and the Xbox, they're running on x86 chips too.
That's a great point. The consoles are basically specialized x86 PCs now, which makes it incredibly easy for developers. They make a game for x86, and with some tweaks, it works on PC, Xbox, and PlayStation.
So if you're a gamer, sticking with x86 means you actually get to play the games without needing weird workarounds.
Right. It guarantees compatibility and performance. It just runs natively.
I like the specific example the source gave about creativity, like opening a family photo album from the cloud, applying filters, and sharing it.
That sounds simple, but think about the math. A 64-bit x86 CPU is processing millions of pixels instantly to apply that filter. On a less powerful or less compatible architecture, you'd see lag, you'd see the spinning wheel. With x86, it's just instant.
There's also the simplicity factor. I think we take for granted that when we want an app, we just download it.
That's the ecosystem. You don't have to hunt for special ARM builds or weird versions for your specific laptop brand. You just download the PC version. And because Intel and AMD are constantly at war, prices stay relatively low.
Okay, that's the home user. But we have to talk about where the real money is.
Yeah.
The business world. The business backbone.
The office environment is where x86 is almost completely immovable. It's the concrete foundation of the global economy.
Why is that? Is it just that they're stubborn?
It's reliability and horsepower. Think about a massive Excel spreadsheet, you know the kind, with 20 tabs, complex macros, pulling data from 3 different servers.
That's the kind that makes you want to cry.
The kind that makes you want to cry? Yes. That needs some serious, heavy lifting from the CPU. x86 chips are incredibly good at that kind of complex calculation.
It's not just Office, right? It's the really specialized stuff.
Exactly. CRM systems, accounting software. Some of this code was written 15, maybe 20 years ago.
And it still runs.
That's the superpower of x86, backward compatibility. A business can often take a program written for Windows XP in 2001, and it'll still run on a Windows 11 machine today. If they switch architectures, that software breaks instantly. They'd have to spend millions rewriting it.
That is a huge incentive to just stay put.
It's the golden handcuffs.
There's a really interesting point here from the IT side of things. Virtual machines. Can you explain that simply?
I'll try. So historically, if you needed a server for email, one for files, and one for a database, you bought 3 physical machines.
Expensive. And they take up a ton of space.
Very. But a powerful 64-bit x86 CPU can do what's called virtualization. It can run multiple virtual computers inside a single physical box. So now you buy one monster x86 server, and inside it you run 10 virtual ones.
That saves a massive amount of money.
Massive. Plus, you get modern security features built right into the hardware. It's not just software anymore. The silicon itself has security baked in.
So we've covered home and office. I want to zoom out a bit. We talked about it being a language earlier, but let's talk about the full ecosystem. The source calls it the one-size-fits-all effect.
This is the economic moat around x86. It's this massive library, millions of programs, free and commercial, that already speak the language.
And you have freedom of choice for your operating system.
Yes. You buy an x86 machine, you can run Windows, you can run Linux, you can wipe the drive and install whatever you want. You aren't locked into a walled garden like you are with, say, a tablet.
And the economic impact of that is just staggering.
It is. Having over a 90% market share creates this incredible competition. But think about the jobs. A huge ecosystem of developers, technicians, and IT staff are all trained on this one architecture.
Right. Schools teach on x86.
Exactly. It creates a pipeline. A student learns to code on an x86 laptop, goes to a university that uses x86 servers, and gets a job at a company that runs x86 workstations. It's self-perpetuating.
But, and this is where it gets really interesting today, it's not a monopoly. We have this fierce rivalry between Intel and AMD, and lately, that war has really heated up again.
It's a fantastic rivalry for consumers. Intel created the standard, but AMD has been absolutely tenacious.
The source mentions AMD is really chipping away at Intel's market share.
Yeah, depending on which report you read, AMD now holds somewhere between 25% and 31% of the total x86 market. That is a significant chunk.
And for us, that war is just good news.
It's the best news. If Intel was the only player, we might still have slower, more expensive chips. But because AMD came out swinging with their Ryzen processors a few years ago, Intel had to wake up and start innovating again.
So what does that innovation look like? What's the future of x86? Because you do hear people talk about it like it's old tech. You hear a lot about ARM chips, like what Apple's doing. Is x86 a dinosaur?
It's old in its lineage, but it's definitely not a dinosaur. It's more like a shark-and evolutionary survivor. One of the big shifts right now is something called hybrid cores.
What does that mean?
So traditionally, a CPU had, say, 4 or 8 identical cores. Big muscles, high power use. Now, new x86 chips blend high-performance cores with smaller efficiency cores.
Ah, so it's like a hybrid car.
Very similar idea. If you're just checking email, the chip uses the little efficiency cores and sips battery. But the moment you launch a game, the big performance cores wake up and provide the muscle.
That directly addresses the biggest historical criticism of x86, which was always battery life.
Exactly. It's letting x86 laptops finally compete on that front, and we're also seeing much better graphics built right into the chip.
Yeah, integrated graphics used to be a complete joke.
They were. You couldn't run anything. Now, a modern x86 chip without a dedicated graphics card can handle casual gaming and video creation just fine. It's amazing.
So to wrap this all up, we've covered a ton of ground here. We started by just looking at that laptop on your desk.
And we realized it's not just a box, it's part of this 40-year lineage.
x86 isn't just a chip, it's a platform. It evolved from a 1970s experiment into the engine that, well, literally runs the modern world.
The key takeaways for me would be ubiquity, it's just everywhere. Compatibility, the fact that Intel and AMD software works on both is the bedrock of the entire PC industry. And performance, that jump to 64-bit, is what enables modern computing as we know it.
So here's the final thought. We're always chasing the newest shiny object, right? New phones, new headsets. But x86 is this constant silent presence.
That brings me to a thought I'd like to leave the listener with. x86 is often viewed as legacy tech. But that is a mistake. It is a living platform. Whether you are streaming a theories, which is likely served from an x86 server, or crunching global financial data, this silent workhorse is continuously adapting. It's adapting to new demands for energy efficiency, it's adapting to new security threats, and it's adapting to AI. It isn't just surviving. It is actively shaping the future of computing. It's the invisible foundation that allows the rest of the digital world to even exist.
That's a great way to put it. So next time you open your laptop or you hear that fan spin up when you launch a game, give a little nod to the x86 engine inside. It's doing a lot of heavy lifting so you don't have to. Thanks for joining us for this deep dive, and we'll catch you on the next one.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. please feel free to click on the link in the description below to discover more podcasts.